Hi guys, Dr. D is here to talk to you today about Module 3, the expectations, what you're doing, and how I can help you better understand the work. I hope you guys are doing well. I'm about to grade Module 2 work and provide feedback and an announcement with that. But let's get started. So I have my laptop here and I've got everything pulled out. If you want to, you can pause the video and open up and follow along. I'm going to be talking about the short paper you're going to write and the discussion you're going to have and the content that you're going to be covering in Module 3. So let's go ahead and start. So in Module 3 you're going to be learning about the meaning of statistical significance, p-values, and type 1 and 2 errors in statistics, inferential statistics. The word inferential comes from inferences. So if you're using inferential statistics, you're using analyses that are guiding you to make an inference, which is a suggestion or a correlation, never a causation. And it's supposed to be very strong in the relationship that the two things you're measuring have a correlation or a relationship. And that's where you're going to see significant levels play into hand. Got my water here because I'm thirsty. So that's what you're going to be learning about. Make sure you do your reading. This type of stuff, it's really fun, but it's a little challenging at first to comprehend, and you got to make sure you do all your reading. And I would recommend, in addition to your reading, just look up online and see clear-cut examples. I'm going to be putting a funny picture in our Monday announcement today that shows you the difference of type 1 and type 2 errors that I think is going to make it extremely clear in grasping these concepts. I know a lot of people get confused on these terms, and we'll talk about that in a second. So let's first focus on your short paper 1. It's the statistical significance. You're going to be given an example of a study. You're going to be given the outcome of it, the mean, standard deviation, the t-score from the t-test, as well as the level of significance indicated by p. And p is less than 0.05. That's the largely accepted level that that a relationship is significant between two variables at 0.05. And I'll talk a little more about that. And I'll talk to you actually about that in the rubric. Let's get into the first paper. I'm going to pull the rubric up here. Very short rubric. And of course, what this paper wants you to do is you're going to write a brief paper explaining what the author means when she says that the results were significant. Meaning, what does it mean to say that results are significant? Explain what a p-value is and how it relates to statistical significance. As a reminder, M stands for mean, SD stands for deviation, standard deviation. The T is the score of the t-test, and the P is the p-value. Turn to page 377 of your book, Discovering Statistics Using IBM SPSS Stats, for help interpreting the results listed. And you can also look at short paper 1 guidelines and rubrics, and that's what I have pulled up for you. So the point of this paper is you're going to show me that you understand what it means when a result is statistically significant. Let's look at that rubric. I'm going to read from the exemplary column, although I do pull from the proficient, just so you get a well understanding of what this paper is about. Number 1, the description of statistical significance meets proficient criteria and explanation is succinct and needs no further clarification. That means when I'm done reading your paper, I'm not left going, they left something out, or they needed to expand more on this. They covered what a mean and standard deviation was. They kind of said it's significant only at the 0.05, but they don't explain why 0.05 is a level of indicator for significance. Moving back to proficient, clearly and accurately describes the meaning of statistical significance. So just make sure your answers need no further clarification. And what that means for me is you're going to provide a well-written description of what stats significance is. Let's look at the second one, explanation of the p-value. This is a good one. Meeting proficient criteria and explanation is succinct and needs no clarification. The proficient indication says clearly and accurately describes the meaning of a p-value. Just make sure again that we need no further clarification. I'd like to take this time to talk to you quickly about p-values. And in psychological research, 0.05 is a widely accepted level of significance. And what the 0.05 means is on the other side of that, there's 95%. And if you've ever seen a one-sided or two-sided tailed bell curve, it could go out like this, and it stops if there's an indicator at the 0.05 line. What that means is when you see p less than or equal to 0.05, that means that the other 95% is meaning that the two variables you're measuring, the relationship is due to the interaction, and 5% is due to chance, or the variance is due to something else. So think of it this way. Think of $1 as 100 pennies, and if I have 95 pennies, I more or less have $1. If I have 5 pennies, I don't have $1. I have a nickel. So the reason I gave you that example is to say running and smoking. Those who smoke are slower runners, can run less distance than those who do not smoke. We do the test. We find out the relationship between smoking and running is significant, and in fact, smokers run less miles than non-smokers, and it's significant at the 0.05 level. The interpretation for that is saying 95% of the variance is accounted for by the relationship of those smokers, of smoking and running, that there is a significant relationship between smoking and running, and that 5% or less is due to chance or something else we're not accounting for. As always, there's always a third variable in statistics. For instance, what if I said single mothers, the relationship of income, single mothers, and healthcare? And my thoughts were single mothers have less affordances to better healthcare than those who are in a dual parenting family. Well, what if we find out it's significant, but then we realize almost all single mothers are in low SES status, meaning they don't have money, and the dual partnership mothers who have a husband or a partner have higher income? So we would say income's a third variable that is influencing our relationship. That's a little ahead, just fun to talk about, fun to realize. I want to come back to the talk of explaining the p-value. So once again, if you do a study like caffeine and hours of studying, if we find out that those who study while drinking caffeine study for longer hours, we know that, and it's significant at 0.05, we would say that 95% of the variance is due to the relationship between caffeine and studying, and that 5% or less is due to something else. And that's really significant, just like saying 95 cents is far closer to $1 than 5 cents. That's just the way I look at it. I hope it doesn't confuse you. And we have other significant levels. 0.05 is your widely accepted one. People get stringent and they go down to 0.01, meaning 99%. If you're wanting to be very accurate, you could look at it from a 0.01 level and say, look, I need 99% of the variance to be related to the variables, and have 1% be something else. That's like a very stringent measurement. So that's like saying 99 pennies versus a penny, 95 cents versus 5 cents. And then people get even more stringent and they go down to the 0.001 level. And think about that. Depending on what you're studying, you might need it to be at the 0.001. That's 99.9% of the significance is due to the relationship of the variables you're studying. Could you think of why you would want it so stringent? What about in medication and forming new drugs? Would you want to put a drug out that is 95% effective versus 99.9% effective, saying that when the drug was introduced, it was significant at the 0.001 level versus 0.05? On the flip side of all this, there are some studies that are wonky, and you got to be careful and look at their significance, because some people have it at the 0.10 level, and that's 10, 90 to 10. That's like saying 90 cents to 10 cents. 0.10 is 10%. So they would say, hey, as long as 90% is there, it's significant. So to recap, you have from biggest to smallest, you have 0.10, that's 90 cents to 10 cents. You have 0.10, 0.05, 95 to 5. You have 0.01, 99 to 1. And then you have 0.001, which is 99.9 to 0.001. So can you see how, as that dials down, the relationship gets more and more significant? So let's finish off the rubric. The last one's called articulation of response. Again, that's something that I look at, and I make sure that the submission is free of errors. There's citations, grammar is well done, organization. For you, this means make sure your spelling is correct, your organization. I live for organization. As a researcher, you need it, and you live by it. And make sure your spelling, your syntax, your grammar, and moreover that you just are very organized in your paper. I know you guys have worked with me for a while now, so I'm glad to know you understand what I expect. I would recommend using your headers and subheaders, and you can make header number 1, description of statistical significance, header number 2, explanation of p-value. And that's organizing your thoughts and your writing. That about wraps up the paper rubric. That was a really fun discussion on p-values, by the way. I myself, we look at studies in higher education. We use the 0.05, which is just widely accepted. When we're working with salaries, faculty salary perhaps, we may use 0.01, but more likely than less, I use the 0.05. Because I'm looking at things that aren't serious where lives are at stake, like medicine, healthcare, things that are going into the body, and is the medicine effective or not. Those medical research, health statistics are different than higher education. Okay, let's switch gears. Let's look at your discussion. It's important to talk about this because understanding type 1 and 2 errors are important in statistics. So I'm pulling up your discussion, and it says here, you're going to describe a research question the research question you're pursuing for your final project. When drawing your conclusions, what would a potential type 1 error be, and what would a potential type 2 error be, and why is it important for researchers to understand these errors? I'm going to pause right there and say, while I'm looking at your discussions and reading them, I'm going to be looking for whether you told me your research question stated a potential type 1 error, stated a potential type 2 error, and told me why it's important to understand these errors. So right now you can see there's 4 things that I'm looking at in your post: your research question, the potential type 1 error, the potential type 2 error, and why is it important to understand these errors. Now that's your initial post. Let's take a look at your response posts. When you're going to respond to your friends and colleagues in the class, you're going to tell them how much you agree with their type 1 and type 2 potential errors that they put, and provide a perspective on your own on why understanding those errors are important. So what I see there is when you respond to a friend or classmate, you're going to talk about the type 1 and 2 potential errors they listed on their research question and provide your insight on why these are important for their study. Okay? So let's go ahead and talk about type 1 and type 2 errors. Again, I'm going to be putting a funny picture that's really clear cut on what these are. I'm going to pull up my notes here. Now, a type 1 error is a false positive. Type 1 error is a false positive. A type 2 error is a false negative. I'm going to say that again. A type 2 error is a false negative. Now you can think of this as type 1 is an incorrect rejection of a true null hypothesis, meaning it's an incorrect rejection of a true null hypothesis, meaning a false positive, meaning that we incorrectly rejected real results. Okay? Type 2 error is we failed to reject a false hypothesis, which is a false negative. That we failed to reject a false hypothesis. And what that means is, this is coming off of the picture I'll send you, but a type 1 error, a false positive, is if a doctor told a man that you're pregnant. meaning the results came back that they're pregnant, and it's wrong. It's a false positive. It's not right. A man can't be pregnant. So the results are wrong. But we keep them. So keeping wrong results. Type 2 error, a false negative. A false negative is like a doctor telling a pregnant woman who's like 9 months or more pregnant, saying the test came back and it says you're not pregnant. Well, she is pregnant, right? So that's a false negative. If the tests come back and say she's not pregnant, that's wrong. It's a false negative. So we want to think about this in our own research study, okay? So how could we see a false positive and how could we see a false negative? Based on your readings and research, I look forward to seeing your examples in your discussion posts. And you can always turn to that post I'm going to give of this picture so you can understand what a type 1 and 2 error are. Alright, well that wraps up what you're doing for Module 3. I hope you guys are doing well, and I will talk to you soon. Take care.